Hello everyone. Today we'll talk about the future and evolution of the open source virtualization platform in the context of DevOps, cloud native, DPUs, all the words you might have heard, and where you want to understand them a bit more and how they will interact with virtualization platform. So first thing first, I'm Oliver. I'm the CEO and co-founder of the company called Vates, doing open source virtualization solution. I'm a former system administrator using Zen since a while now. I initiated the project Zen Orchestra, a web management tool for Zen Server and XCPNG, and then XCPNG, Citrix Zen Server fork, which is now hosted inside the Linux Foundation, inside the Zen project itself. If you want to get access to the slides, then you can go on vates.fr/fosdem22, and you could, if you want to click on the links, explore them more in details. So today the plan is to talk about the trends. So what is the trend first? And also how those big trends are, shaping the future and the way we are dealing with software, and compare that to the real impact we've seen ourselves as a software editor inside the usage of different platforms, virtualization platform, bare metal, cloud, and things like that. So we'll use our experience, and the goal of today is to explain and show what we saw in that area, and then we'll try to conclude on what we believe that trend will do in the future. So first, we talk about a trend. So what is a trend exactly? So a trend is a general direction in which something is changing. So this is something happening as we speak, and this evolution is triggering a lot of different things, and we'll explore that in detail. So that's, to me, that sounds important to talk about what is a trend first. So the big thing that started in software development and as sysadmins and user virtualization platform, this matters a lot because the way software is done and distributed will have an impact on the way we'll operate that. So in short, the old model, you probably know all of this, is a waterfall model, which is not really flexible, and you got silos, teams working in each, in their office and not talking really each other. Release cycle were very, very long, and then you got a lot of QA and back and forth and so on and so on. And because of the limitation of this model, we switched to the agile model in early 2000 with a better development process. So in short, it means that developers will actually talk to the end user, the customer, asking the application, for example. So this gap is, filled by this definition of doing things that way, but that wasn't enough to solve all the production and delivery issues. So that's why we had things we call DevOps, which is not just a technical change, but more than that, it's more cultural change. And for that, the main focus of DevOps is to focus on constant testing and delivery. It means that testing while you are building the software and delivering the software very, very often, maybe multiple times in a day, is something within the core of the DevOps culture. So that's why the goal is to get people, from dev, QA, sysadmins, and even security working together during the whole process. And to achieve that, you need automation and better tooling, because otherwise you couldn't keep up the pace. So all of this is the theory, the three main things: waterfall, agile, DevOps. But after that, what does it mean for real? So the consequences of those trends are outside the complete, I would say, cultural shift. Technically speaking, what does it mean? It means you have to industrialize your IT to get automation and get tooling that's able to manage this kind of automation. So for example, industrialization mean like you need to have some tools and practices to achieve that. You need source code management, so Git, GitLab, GitHub, and things like that. CI/CD, infrastructure as code, and identity management even. If you want to centralize everything, Those are the big processes to go from the small shop doing a software to something very streamlined. So that's why I think the right word is industrialization. So streamlining the software development in short. And to streamline, you need automation. So it's not just about process and culture, which is very important, but it's also releasing things very often, make reproducible builds, detect problems, and all of that. And for that, you need tools you can count on. And just to give you a rough, short evolution of those tools, we had maybe 20 years ago some what we call custom scripts, in-house solution, things you develop for your own IT, and then more tools came providing a kind of standards or best practices that you could reuse within your own organization. And finally, I would say we got a kind of modern tooling nowadays. For example, to have infrastructure written as code, like using Terraform, automation and configuration with Ansible, as I said, CI/CD, auto-generation of images, container orchestration, observability, all the things that allows you to, achieve this DevOps culture, which is again more than just technical but also a culture. So those tools are somehow required or alternative. That's just some example, not a perfect or exhaustive list to achieve that. So what about virtualization in the end? What's the connection between all of that? And that's why we wanted to give you at Vates our perspective, and through me our perspective on that, and how it's changed the way to use virtualization. So Vates is a software editor since late 2012. We are specialized in open source virtualization. So as I said, we have two main things, projects, I would say. We have Zen Orchestra as a kind of centralizing all the virtual machine at one web UI, but even more than that. And you got the virtualization platform. The thing is that as a fully open source project, we are really connected to our users. So it means that we have a lot of discussions with them, even support, but even using forums and feedback and things like that. So and since almost now it's almost 10 years, we have so many discussions with a lot of different companies, could be public, private sector, education, whatever, even heavy industries, IT, travel agencies, whatever you name it, from companies using one machine to big companies using thousands of machines. So that was a pretty interesting way to gather feedback on how it evolves and the way it evolves at sometimes a different pace depending on which company. So obviously, we got some bias because our users, the people we are talking to, are mainly system administrators. They're interested in open source software, otherwise they wouldn't use a fully open source solution for the virtual machines. And however, that's interesting because they are using those tools. They are not trying to promote anything. They are users, so their feedback is really interesting, precious for us, allowing us to modify and to shape our solutions themselves to fit the usage. So that's why I think it's relevant, to discuss that today. And the first information is the fact that in the last 2 years also ish, we started to have a different kind of end users. We still have a vast majority of system administrators, but now we start to discuss directly with developers who want to get their application running on the virtualization platform or using containers on top of the virtualization platform, but also people coming outside the open source world like VMware users. And we've seen it sometimes, at some point, it's not that different in the end. It doesn't change the whole message and the whole data we got from them. So the first reality check we can tell is there's a big lag sometimes between a trend like the DevOps culture and the reality. And this is pretty obvious, but sometimes, you could be tricked by just, looking presentation from big companies using latest very cool tools that everyone is using that, and you're almost, completely has been of because you are not using this and that. So Believe me, that's not the case, and that's why I say no judgment there. So there's reason for that lag, and why people are not adopting technologies as they're emerging. So the first big point, I would say that the existence of legacy. There's a lot of legacy in a lot of companies. So legacy means old applications, all the way to deliver software, old infrastructure, even things that couldn't support, some flexibility. And also sometimes you do not have what I call the scale effects. Scale effects are, for example, if you have a lot of machines, it makes sense to adopt practices that will help you to be more productive, because even if it's small gain for one machine, like using automation, if you are creating or removing machines like 100 times a day, then it will pay off very fast. And if you have a very small infrastructure, not moving a lot with, let's say, even virtual machines that are not changing, or you're not installing any virtual machine per month, then it's more complicated to adopt those practices. I mean, the return of investment is not always really great. The other part is you need skills, because you might work on a lot of stuff already on your plate, and then you need to get time, you need to have some training from your company on using those technologies, and it's hard without having more people on board to do that. And in general, that's what people say about DevOps. It costs more to get it, because you need skills, you need to be trained, and obviously you need to get time to reach to that. And again, sometimes it's a bit overkill to use the latest technologies within your company for a lot of reasons, wide range of reasons, but that's the main reason, I think, explaining the lag between all the training we could hear during conferences and things like that and the reality on the ground. So going more into examples, if you are a hyperscaler, so hyperscalers are people, companies deploying 1,000 machines every year, and even more than that. Their scales effects are huge, because again, if you get some improving performance or time or reproducibility and things like that on one machine, and then you could scale with a huge number of machines, that it's a clear win situation. It's less clear if you have a small infrastructure. Also, those hyperscalers, like again AWS, Facebook, Google, and things like that, they don't have any problem. They don't have any problem to get all the best skills available on the market, because they could, pay a lot for it. And it's harder in another structure, which might not be focused on IT like they are. And failure is possible if you are a big company, an hyperscaler. It's sometimes less acceptable in other parts of, companies in other sectors. That's why, for example, it's also a mindset, but industry is harder to change than services in general, because in industry you have something physical, tangible, that you have to produce, and that's a lot of costs involved. And if you fail, or if there's a problem, this will cost very, very huge amount of money. And this way they got a more conservative approach, and that's why they got more legacy also on their way to build software, and so on and so on. So you could somehow try to get a different level of companies. Some are adopting technologies very fast, or even creating the technology. Some are taking more time, or using new project to adopt the technology in a few years, and then you get the average. So that's roughly our data here. So it's not a perfect statistical study, but it gives you a right order of magnitude that it could be very, very late in the latecomers, especially, for example, in heavy industries or things like that. So, now, what about the real change in the last 10 years that we could, check and see on our side? So, our starting point, as I said earlier, is 2012. So, we were already seeing at that point people migrating from the plain Zen you install from your Linux distro with flat configuration file and no pooling or clustering available, things like that, transitioning to something more, I would say, turnkey integrated, like a Zen Cloud project, which was the open source thing than Zen Server. And it was, in the end, more user-friendly. And on top of that, the user, and in fact, that's why we created the product in the first place. We created Zen Orchestra because, as our own customers, we needed a central management console that was a web application, and we discovered that a lot of people were interested by that. And the goal in our mind was to do something that was, a web centralized, but also simple to use and deploy for the users. And that's how we had our success in that area. But managing just the virtual machine wasn't enough. I would say pretty quickly after that, after our initial release of the Zen Orchestra, people wanted to have more simplicity for more tasks. They wanted to, remove their own internal scripts they were using to make some, manual backup and things like that. They wanted some just, click interface where they could even delegate to people less trained to do their backup, to even delegate existing virtual machines to their users so the system administrator won't have to reboot, let's just say, for example, a Windows VM that might be stuck or having a blue screen of death. Then you could just give the permission to a user to log into Zen Orchestra. We'll see only the virtual machine with this permission, and maybe to force restart the VM. So that was, I would say, the start of going outside the management and starting to do more stuff with it. And in fact, it was just the start, because after that, something like in 2015, 2016, we really started to feel more pressure because people were starting to change the way they were using virtualization. Before that, it was a kind of, a static environment, and then people started to require to build more and more machines and more delegation with self-service, and start to use containers inside their virtual machine. So for that, Cloud Init was a great solution to be able to just get your template with Cloud Init and then pass your SSH keys and things like that. Improve backup when you create, for example, a lot of different VMs. You don't want to add the VM every time to the job, so you do just put a tag, and that will be entirely with a full automation on which VM will be backup, because there's this tag and that tag. So it's far more flexible, and it makes sense because people were creating more and more VMs, and I would say that's the important thing to keep in mind. They basically kept the legacy at some point and continue to grow their IT around, on top of the rests, without touching the old system or fixed VM. But they wanted to start more VMs. They were more short-lived also, because they were created with Cloud Init, and they just wanted to do something inside, and when they finished, they might remove it, and so on and so on. So this more flexibility stuff, came more and more after years. And then the last trend that was, very visible was, DevOps. And it means, from a virtualization platform perspective, that you need to have integration between your application, even your virtualization platform. And we started to have users using a lot of our API. And to be fair, that wasn't really planned on our side. We built an API for our internal usage to get the web clients communicating with the server, but we didn't realize that was in fact something people expected, and so they started to use it. They started to build, other usage we couldn't even, imagine on top of the API. So that was great. And when I talk about integration, for example, you could have, chat ops where you send backup reports or alerts to Slack or whatever. So, integrating things together inside the IT and removing the silos and having one entire IT infrastructure connected was more and more visible and present in the way we're using our stack, in fact. And it continued that way until we decided to say, okay, we want to be what we call cloud native, which is just a way to say that you could be controlled by some really interesting tools like Ansible, Terraform, Packer, and things like that. So you could control Zen Orchestra and XCP-ng remotely, but you could also use Zen Orchestra and XCP-ng to send data to other application, other API. For example, synchronize the IP addresses of your virtual machine inside Netbox, things like that. And also, we realized that our internal API wasn't meant to to be used like that in an easy way. So we started to create a new API, a new public API that would be easier to use, but just for the public, usage. And so hybrid cloud, cloud native, all those words are basically, it's a kind of shortcut, but still you got the idea. The ability to easily move your load from the cloud to your on-prem infrastructure and vice versa, and using the same recipes from building in the public cloud than on your local infrastructure. So if you can do that with your on-prem open source virtualization solution, that's fine, because that's what people really want more and more, as we've seen in the recent years. And that's not it. And we also have to prepare the future, and the future is we want to keep virtualization for a lot of reasons, but it has to keep up the pace on the technology usage and things like that. So for example, we kind of ported Runx to XCPNG. Runx is basically containers, but with Zen isolation. So that's pretty handy to keep up, exactly the same podman or Docker commands, but just replacing runc by Runx. Obviously, hyperconvergence is something more and more asked nowadays. The big challenge is to make it easy to use and to install and maintain, because it's not trivial to maintain a hyperconvergent solution. And even to leverage data processing units called DPUs. Those are specific CPUs, massively parallels in general, that are able to deal with, for example, network or even storage in a way that's very fast. So to remove this kind of massively parallel load from the x86 CPU and put it to a dedicated hardware, which is something that, for example, AWS is doing with Nitro. So in the end, is virtualization still relevant nowadays? And I would say it depends. Yes, if you are keeping up the pace as a software editor or even a user using a platform that's not just as it was 10 years ago. So you need to adapt on this new challenge. And because we have more and more developers, you need to improve your user experience, your user interface, because people that weren't used to that, but more used to cloud tools like on AWS or DigitalOcean, whatever, they were used to UI that are a bit different than the traditional one into virtualization on-prem. So that's why you have to get a platform that makes sense to them too. Obviously, again, API as a first-class citizen is more and more important with a decent documentation. And to keep up something simple and easy to deploy while being compatible with the tools that users are using to communicate with their instances in the cloud and things like that. So the potential is pretty great, because in fact, virtualization can do a lot of things very well. You can do, for example, almost everything, and that's the point of my last slide, is everything could run on top of virtualization. And the goal is to make it even more transparent, even more performant. So the developer won't have this in its path when he is working on, for example, on a program or things like that. People want something that's just trivial to use, deploy, maintain, and things like that. So to stay relevant as a software editor in a virtualization platform, we have to get into that direction in terms of compatibility, integration, and things like that. And finally, as you can see, all we did here was thanks to the way that our users were giving us feedback, and we were listening. So we just created our tools initially for our own requirements, and then since we started to discuss with our community, we really discovered that people wanted more, and that's how we build our stack today. And I think this is a good lesson that trends are pushing for new ways on using platforms, and to stay relevant, you have to adapt on those users' needs. So I hope it was clear. And then finally, if you have questions, you can go in the chat. Thanks a lot, and bye-bye.